everyone, and welcome to this MECC case walkthrough. I'm Emilie Williams. I'm a mining engineer and an instructor at the University of Toronto. In this case, designed by Jack Franken, we're going to solve the duck hunt. So this case, we are an ornithologist. We're studying the impact of duck hunting season on the duck population. We're going to be analyzing a scene that's been provided with different colors, and then we're going to look at duck movement. So the first question, we're going to use the Scene Numbered tab, and we're going to want to look at the sum of the color values in the given row. On the Scene tab, they haven't provided the value, so this would be a little bit trickier. But with the numbers here, it's pretty straightforward to get the colors and find out the values. So we're going to give an example. If in row 13, the sum should be 19. So if we take row 13 right here, and we sum across, we can see that we get 19. Now, one thing that's a little bit tricky here is we want the Excel row, which is different than the row of the scene. So for example, this is row 13 in Excel, but it is the 12th row of the scene. So that's a little tricky, and we're going to need to pay attention for that. So the first thing we're going to do, we're going to create a function called SumLevel1. And we're just going to take the sum of this across, and we're going to copy that down. And that is the sum of all the colors in a given row. I'm going to give that a range to make it easy to look up on our case. Now, if we were just looking for the row in the scene, it would be easy to use an index function. But again, we have an offset. So there's two ways we could do it. We could do an index with the row -1, or we can create a row lookup. Let's do it this way. We're going to call it row lookup. So in this case, we have 26 rows, but we want to start at 2. So we need the sequence function for that. Sequence, we want 26 rows. We are going to skip the columns, leave that blank, and we want to start at 2. And now we have the numbers 2 to 27 that we're going to be able to look at. So we're going to give that a name as well. And of course, the shortcut for giving a name is Control-Shift-F3. You can also type in the name box. So we're just going to do a little test, and we're going to make sure that we're doing that. We've got this correct. So we'll start here. We're going to use XLOOKUP. We want to look up our row in our row lookups, and we want to return the sum from level 1. And that gives us 19, which is our answer. We'll just copy this down, and we will refer to that right here. Now we want to know how many of each color is in a row. We're going to build on the same chart we had here because we've already got the rows that we need to look up. In this case, we're going to use the fact that we've already got a legend built for us. So we're going to use 2 rows of the colors here, and that's going to spread that across the top that we can use in our function. What we want to do in this case is we want to count. The question says, how many of each? So we're going to use the COUNTIFs function. Our criteria range is this. We're going to lock the columns, and we want to count first the zeros, and we're going to lock the rows. This tells us there are no zeros or whites in the first row, which makes sense. If we drag this across, we can see that we only have 1s, and visually we can check that's the case. what can be a good practice to do this is we know that we have 20 across, and we're just going to do a little check to make sure that everything worked out. We got 20 in all of them, so therefore we haven't forgotten any rows or colors. So that's good. Now we know how many are in each of the by color, but we want, our case is giving us the color name, not the color number. So what we're going to do, we're just going to do it at the bottom here, just because we don't want to create any offsets in this, which would affect our rows, which would affect our references later on. So we're just going to do it down here, but we can look up no problem on the bottom. So we're going to use the to-row function again. And now we're going to use this. So now we're going to be able to use the index function, and we're going to match on the color. And I'm going to call this color names, and I'm going to call this color count. And we already have our row lookups. So now what we can do is we're going to do the index of our color counts. Color counts. Our row number is going to be XMatch, our row here in our row lookup. And our column is going to be XMatch blue in color names. And that gives us 16, which is the example. Now, you don't have to use defined ranges if you don't want to. I just find it's easier than clicking back and forth between the scene and the case. So again, we'll just copy this down, and we can refer to that over here. Now we're going to be looking at the row for the given cell, not the row number, again, within the scene. So we're going to start here, and we're going to call this start row. I'm going to do it over here because, having looked ahead, we're going to need to build on what we're doing here. So I'm just making sure that I've given myself some room to do that later on. So there's a few ways we could do that. We could definitely take in this case, the right of the cell, but that is a little bit trickier when we get down to the fact that some of them have 2 digits. In this case, the easiest is going to be to use the row function and the indirect function. Sometimes indirect can be tricky if you've got a very complicated file, but this case is pretty straightforward, and it will not slow your computer down very much to use the indirect function. So we're going to go row, and then we're going to say indirect. So indirect is saying, don't just take this cell, take what it means. So in this case, it's reading the cell G119, reading that to say A8. So rather than finding if I just did row of this, it would take G119 and give us 119. That's not what we want. We want what's in that cell, so we need to use the indirect function. And now we get the value of what's inside, which is 8. So again, we're going to copy that down. And we have solved level 3. And we're just going to check 17 between 15 and 20, 6 between 5 and 10, and 5 between 5 and 10. Now we're going to do the same, but for the column. And I'm just going to bring this down with us to make it easier as we build, though we're not going to use it in this case. Now we want the same. We want the column of this. So instead of doing row indirect, we're going to do column indirect. of this. And that gives us 18. And R is the 18th letter of the alphabet. We do that, copy that down, 18. We can see that C, third letter. So we're bringing that down. Okay, let's copy that over right here. I'm going to bring my headers and my examples down with me again. Now, in this case, we want to move. The duck is moving one cell each second, moving from left to right. When we move from left to right, we're going to be increasing the column number. So what we're going to do here, we have a movement. We're going to do end row. We're going to do end column. And here, I'm going to do the end cell. Now, the duck is moving left to right, no vertical. So the row is going to be the same. But we're going to bring it along even though it's the same because we'll need this for our cell, our end cell. Now our column is moving. So we're going to take our start column and we're going to offset that by 6. So we're going to add our 6. Column 1 plus 6 gives us column 7. So now we know the coordinates of that, which is row 13, column 7, and we can use the address function. When we type in address, it asks us for a row number and a column number. So our row number is 13, our column number is 7. Now, if I do this, the default argument is to give us a locked reference. So this is correct, G13, but it's not the right format. The way around that is to type in the format. So 1 is absolute, and is the default value. If we type in 4, which is relative, that means neither rows nor columns are locked, and we get G13 in the format we want. And that is the answer there. So I'm going to copy this down, and we'll bring it over into our answers. Oops. Copy that down. And I'm going to bring that over here. So we have it again. Now, in this case, the duck is moving from right to left. So in this case, we need our columns to be negative. So what we're going to do is change our columns. Our start column and our start row are the same. Our end row is the same. But now, instead of adding our movement, we're going to subtract it. And now that gives us from column 22, offset by 8 to the left, gives us 14, which is N6, and that's our answer. Forgot to check, but we can see here that our answer D12 is in the proper range. G16 is also in the range, as is O21. And we can go back up and check our answers for all the other ones, and they are in the correct range. And we're going to copy this down one more time for the last level. In this case, we have ducks that are moving left to right, and we have ducks that are moving from right to left. And as we can see here, we do not have the correct movement. We've gone off the Excel grid, and that's why it's giving us a value. So we're going to do one more thing to change that. We're going to add in direction. And what we're going to do is we're going to do an if statement. What we know here is that if the starting cell is in column A, then we need to go right. So we need to add 7. If it starts in V, we need to go left, we need to subtract 7. So we're going to do, if our start column equals 1, then we want to add, we want to go in a positive direction, so we'll say equals 7. Otherwise, we want -7. And now what we can do is our end column, we can change this and we can say +7. And if this had been in column V, as we'll see on the next example, I'll just copy it down so we can see what happens to column V. It knows it's not 1, so therefore it's minus. In this case, we only have 2 situations, which is either A or V. So an if statement is the simplest way to do that. So we can see here, we are starting in column 22, moving 15 to the left, and that gives us G7, and G17, which is in the range. So let's copy it all down. And here we have finished all the questions. Now, if you've noticed, I did everything in the same columns. So this is always the start row, this is always the start column going through, and this is going to help us out now that we're getting to the bonus questions. So we'll go back up to the top. We're going to go back to our scene actually for the first bonus question, which says how many cloud cells are in the scene. So our cloud cells are the white ones with 0. So we're going to use a count if our whole scene here, and we want zeros, which is 40. So we can copy and paste our link to that. Now we want how many cells in the scene are not blue. So if we are to, a couple ways we can do this. Let's lock this range. We copy this down, and we can do the total number of scenes is 520. And we can say equals 520 minus blue. So therefore, 98 of them are not blue. Otherwise, we could, of course, do the sum of all the other colors, which would give us the same. In level 7, now we want, excluding the example, we want how many ducks are flying from left to right. So we're going to go back down to level 7, right here. And we're going to say, if we're flying from left to right, then we have a positive number. So we're going to if our direction is greater than 0, 1, otherwise 0. So therefore this one is going right to left, so it's 0. And I've done it with 1s and 0s so that I can take a sum. I take the sum here, and that tells us that 11 ducks are moving from left to right. So that's this one, which is in, and all of these should be in A. Which row appears most often across all the data, excluding the examples? So here I've set it all up in the same column, starting with 3. The one thing I'm going to do before we proceed with our bonuses is I'm going to take out the examples just so they don't affect our results. The headings are not a problem when we're doing our numerical calculations. They'll just get ignored. There we go. So now all of our rows are lined up. So which row appears most often? When you have a numerical value, you can use the mode function, which is the most common value. So we'll do mode, and that's the row. And that is going to be the start row because it's in the data. So we're going to start with level 3 right here. And we're going to go all the way down to level 7. That's the end. Mode of that is 26. Now we want actually the same thing. We're going to be able to copy that. So because we've already picked our range. Oh, actually we don't want the data. We want the row number for the answers. So that is going to be our end row. So what we are going to do here is for the questions in which we didn't do that. Actually, the rows are the same for the answers and the starts because we only moved left to right, but we're going to put it in the correct column because it will be easier to sum them up. So we need to do this for level 4, and for level 3. We're going to add in end row. We don't need it for, only level 7. It's always tricky which levels are included. So in this case, we only need level 7. I didn't need to sum that up. Okay, so we want sum of the row numbers for the answers. Go all the way down. And end row is this set of data right here, which gives us 271. So I hope this walkthrough has been helpful, and good luck with the rest of your competition.
When you're playing at the highest level, you can't guess. You need to trust every movement. When you're playing for everything, your gear has to be perfect. The shape, the speed, the precision, all of it has to feel right. Built with pros, made for esports.